this example is asking us to find the real zeros of this polynomial. So first of all, take a look at the degree. The degree is 4. So the maximum number of real zeros will be 4. Now we can use the Descartes' variation in sign to figure out the possible numbers of positive real zeros and negative real zeros. If you look at f of x here, every single term here is positive, so there's no variation in sign because all the terms have the same sign. And what this tells us is there are no positive zeros, or we'll say 0 positive zeros. That's actually a lot of information. That means that when we do our rational zeros list, we will know not to check any of the positive ones. And then to figure out how many negative zeros there could be, you need to find f of negative x. So remember that when you find f of negative x, every term with an odd degree will change sign. Every other term will not. So let's write this down. So we have 3x to the 4th minus 4x cubed plus 7x squared minus 8x plus 2. So now we'll look at the variation in sign of these terms. So here's positive to negative, there's 1. Negative to positive, there's another 1. Positive to negative, there's another 1. Negative to positive, there's another 1. So there are 4 variations in sign. Remember that Descartes' law says that there is that number or less an even integer. So subtract 2, and we'll subtract 2 again. That gets us down to 0. So this means that there are 4 or 3 or 2 negative zeros. Okay, now we'll go ahead and use the rational zeros theorem to see some of the possible rational zeros. So remember, to do that, we look at the constant term and its factors. We look at the leading coefficient and its factors to create the fractions. So the constant term is 2. Its factors are plus or minus 1 and plus or minus 2. The leading coefficient is 3. Its factors are plus or minus 1 and plus or minus 3. So this means the possible rational zeros are plus or minus 1, plus or minus 1/3, plus or minus 2, plus or minus 2/3. But what we can now do is go ahead and combine that with what we learned from the Descartes' variation in signs to note that none of these positive zeros are actually a possibility. So it's either going to be -1, -1/3, -2, or -2/3. Remember, up here we found out there were 0 positive zeros, so that eliminated half of them right away. So now we want to go ahead and test them out. There's a couple of ways to do this. You can plug them in and see if you get 0. I tend to try... Oops, sorry, my phone. I tend to try synthetic division first because I will have to divide it out anyways. So let me go ahead and see if -1 is a 0 by doing synthetic division. So when we are doing this, what we are is we're dividing out x plus 1. Our hope is that the remainder will be 0. If the remainder is 0, that means that -1 is an actual 0 and that x plus 1 is a factor of the polynomial. That's also why I'm dividing it now, because then I'll have the actual quotient already done. Okay, so I'm going to go ahead and put the coefficients here. Okay, and hopefully the remainder will be 0. So we bring down the 3, multiply by -1, add straight down, multiply by -1, add straight down, multiply by -1, add straight down, multiply by -1. Awesome. Okay, cool. So the first one worked. That's very good. We're happy with that. So what this means is not only is -1 a real 0, we've actually also factored the polynomial a bit. We can now rewrite the polynomial as f of x equals x plus 1, which is what we just divided out, times And this here is giving me the coefficients of a degree 3 polynomial. So it's 3x cubed plus x squared plus 6x plus 2. So obviously I can see that this gives me the real 0, negative 1. Looking at the second set of parentheses, I'm seeing 4 terms. So what you could do is try dividing more stuff out, or plugging in more numbers, but since it's 4 terms, we might want to try factoring it. So let's do that. If it's factorable, it'll be a much quicker process. So we're going to try to factor this by grouping, of course, because it's 4 terms. So for the first group, I'll factor out x squared. I'll be left with 3x plus 1. For the second group, I'll factor out a 2. I'll be left with 3x plus 1. Okay, great. So I'm seeing a common binomial. That's exactly what I wanted to see. If I didn't, I would go ahead and try a different strategy, but I can now factor out that binomial, and I have 3x plus 1 times x squared plus 2. So let's rewrite the polynomial again, the entire function again, with all the factors we found. So f of x equals x plus 1 times 3x plus 1 times x squared plus 2. So I can start listing out the zeros now. I can see all the real zeros are appearing. Negative 1. From this factor we get negative 1/3. Notice it was on our list, of course, as it should have been. And this factor here, x squared plus 2, is actually not going to get me any real zeros. That will give me some imaginary zeros, which we were not asked to find. So we found that there are 2 real zeros. They're both negative, which we found out was a possibility from above. And we were able to do that by combining all these strategies together. It makes it a little bit quicker. If you know the Descartes, I won't necessarily ask you to do the Descartes law on the test, but if you know it, it can make it quicker when you're deciding what to test into your polynomial function.